Well, it's summertime here in the Northern Hemisphere, folks, and that means the usual round of unqualified rhetoric from both sides of what some people refer to as a debate about the global climate. On the one hand, you've got the extreme doomers, who latch onto every heatwave as a portent of a dystopian Mad Max-style future and vindication of everything they've been warning us about for years. On the other hand, you've got the climate sceptics, and dare I say it, in this day and age, even still a few climate deniers, who helpfully point out that the seasons are a perfectly natural aspect of life on Earth and that the weather always gets hot in the summer, and we should all stop being so woke and just calm down and get real. And as usual, somewhere in the middle of all that cacophony of online social media noise, the actual scientists are holding their little hands up and offering to provide a data-driven assessment based on empirical evidence and sophisticated climate modelling, and generally speaking getting completely drowned out by all the other more contentious and more exciting content doing the rounds. So let's see if we can tease that science out from all the bluster and blow and have a little look at it. Hello, and welcome to Just Have a Think. I think we'll start here in good old Blighty. Now, for those who don't live in the UK, we have this very famous yardstick by which for the last 50 years we've been sort of gauging our warmer summers. That yardstick was the summer of 1976. I remember it well. I remember a wonderful family vacation in Cornwall and hoping the lovely hot weather would never end. It was undoubtedly a freak summer, with temperatures nudging up to 30 degrees Celsius or 86 Fahrenheit where we were, which was a temperature that, as a 7-year-old, I didn't even know existed. In fact, the town of Cheltenham achieved a high of 35.9 Celsius or nearly 97 degrees Fahrenheit that year. It was all very exotic for our windy little island. Anyway, the point is, since that summer, and particularly in recent years, whenever we've had a heatwave here in Britain, the sceptical types have always said, well, it's no different to 1976. These freak summers come along every now and then. It's perfectly normal. In fact, if you look at these two heat maps, you might reasonably agree with that assessment. They're available on the Climate Lab Book website, produced by Professor Ed Hawkins, who's the climate scientist at the University of Reading, best known for creating the iconic climate stripes graphic that visualises the long-term warming of the planet using simple sequences of coloured bands. The colours in these maps show the average temperature relative to the 1961 to 1990 average. White is neutral, blues are colder than the average, and reds are warmer than the average, with darker reds being significantly warmer than average. So if you only looked at these maps, you might be forgiven for thinking the UK was actually cooler in 2024 than it was in 1976. But then Ed zooms out a bit to take a look at the same 2 years across Europe. What that shows us is that there really was a bit of a freak weather system sitting on top of the UK in 76 that was affecting only a small part of the rest of the continent. By contrast, in 2024, the continental landmass was sweltering, while we only got a small taste of the heat in the southeast of our country. But for my money, you only get the real perspective on the 1976 heatwave when you zoom fully out to have a look at the entire planet. What this tells us is that the overwhelming majority of the planet was close to or below the 1961 to 1990 average back then. You can barely see our little heatwave in the UK. It really was nothing more than a statistical anomaly. Now compare that to the global map in 2024. That's not a localised freak weather event, that's an entire planet that's warmer or much warmer than the baseline period. But again, we're told that you can't judge the whole picture by just one season of 1 year, can you? And quite right, you can't. So let's try some analysis from the World Weather Attribution website. They found that the record temperatures Britain's experienced in the last few weeks would have been extremely unlikely in the climate of the 1970s. They calculated that similar meteorological conditions back then would have resulted in daytime temperatures about 3.5 degrees Celsius cooler than those we've seen this year. Why? Well, because the entire global climate system is carrying more heat energy now than it was back then. So when a heat wave does come along, it packs a bigger punch. It's also worth noting that Europe is warming up twice as fast as the global average, 0.56 degrees Celsius per decade to be precise. Again, why? Well, Europe is a big old landmass, and land heats up much more quickly than water. Continental Europe just doesn't get the benefit of ocean heat absorption in the way that other parts of the world do. Plus, Northern Europe is connected to the fastest warming region on Earth, the Arctic, which thanks to sea ice loss and the feedback loop of reducing albedo or reflectiveness, is now warming at about 0.75 degrees Celsius per decade, which is 3 times the global average. Europe's also done a great job of clearing up its air pollution in recent decades, but removing those particulates means removing some of the reflective aerosols that had previously masked part of the greenhouse warming. Plus, according to the Copernicus Climate Change Service, Europe has also experienced changes in large-scale weather patterns that favour stronger blocking high-pressure systems, longer-lasting heat domes, more heat air transported north from North Africa, and fewer cooling Atlantic weather systems during summer. Those patterns don't create global warming, but they do make European summers much more prone to prolonged heat waves. We also have drying soils on this continent, which means much less incoming solar radiation gets used for evaporation. Instead, more energy goes directly into heating the ground and the air. That creates a feedback loop. Hotter weather dries the soil, dry soils make subsequent hot weather even hotter, and therefore heat waves become more and more intense. The famous US climate scientist James Hansen calls it loading the heat dice. It's a phrase that was illustrated beautifully by John Lang, a UCL graduate in earth science, trade law and environmental policy, and the founder of an education program called Climate Trunk. So each of these grey squares represents a year, and we've got 100 of them here, so that's a century. So far, so good. Using historical data, we can plot how often a once-in-50-year heatwave happened in pre-industrial times, which is the baseline for this graphic. Clearly back then, a once-in-50-year heatwave would happen twice in a century. So let's fill in a couple of squares in red to represent that. Lovely. Now let's see what happens at an average global surface temperature of 1.5 degrees Celsius above those pre-industrial times, which is roughly where we're at today. It's quite a lot more heat waves, don't you think? In fact, at current temperatures, a once-in-50-year heat wave will statistically occur 17 times during the course of a century. You probably don't need me to tell you that heat waves cause major damage to infrastructure, productivity, and human health. So a reasonable person would surely say we want to avoid nudging ourselves up to 2 degrees above pre-industrial times. But according to a 2025 study by the Potsdam Institute for Climate Impact Research, our current trajectory gives us a 20% probability of reaching that level as early as 2047 and an 80% chance of reaching it by 2069. At that temperature level, we're looking at 28 once-in-50-year heat waves in a typical century. That's more than one every 4 years, which leaves precious little time to recover and rebuild from one heat wave before getting clobbered by another one. The recent so-called Scenario Model Intercomparison Project for CMIP7 paper that we looked at in a recent video revises the existing IPCC scenarios down a bit to take account of the progress made on emissions reductions since those scenarios were first published more than 15 years ago. Nevertheless, the draft CMIP7 scenario framework suggests that under its central emissions pathway, global temperatures could approach 4 degrees Celsius sometime during the second half of next century. Now at that level, what we used to call a once-in-a-50-year heat wave would be more or less a normal year, and what would be called a heat wave then would be absolutely unthinkable today. Of course, you folks in the United States have also been experiencing your own heat dome in recent weeks, haven't you? So you're not in the clear by any means. And although it's wintertime down under, Australia's climate's becoming ever more brutal as each year goes by. So we really do have a global problem here. The folks at Bloomberg published their own analysis very recently, providing us with some quite sobering statistics. They point out that September 2023 was half a degree Celsius hotter than the previous September record. Apparently that's the biggest such margin ever and extreme even for an El Niño year. The rate of temperature change has increased in recent years too, which is something we looked at in a recent video. Earth's energy imbalance, which is the gap between incoming energy and heat radiated back out to space, has roughly doubled over the past 2 decades. There were 4 times as many new heat records set from 2016 to 2024 as there would have been without climate change, says the analysis. Physics tells us that for every degree Celsius of warming, our atmosphere can hold on to 7% more moisture. As a result, record rainfall levels are happening 40% more often than they would without our current warming, while record dry spells are hitting us 10% more often. Melted ice sliding off land masses now accounts for more than half of observed sea level rise, and the rate of ice loss observed during 2006 to 2025 was more than twice that measured during 1976 to 1990. Thermal expansion is doing the rest of the job as our oceans reach levels of warming never before recorded, which, by the way, is completely disrupting the geographical habitats and migration patterns of all sorts of marine life, not to mention killing off a good chunk of essential coral ecosystems. And of course, the warmer seas are nibbling away at the floating ice shelves that buttress the West Antarctic ice sheet, which was the subject of another recent video on this channel. I'm not going to prattle on about all the consequences of those changes. I've made countless videos about that in the past. Suffice to say, none of those consequences is good. In fact, I'm not going to waste your time with any kind of concluding remarks at all. If you can't see the blindly obvious with your own eyes, then I'm afraid I can't help you. By all means, leave your thoughts in the comment section below, and as always, I will read as many of them as time allows. That'll do us though. I couldn't make any of these videos without the monthly contributions of very generous individuals who support me on a monthly basis over on the Patreon platform, so a massive shout out to those fantastic people who also enable me to keep ads and sponsorship messages out of your way. Do give us a like and subscribe if you want to see more content like this, and most important of all, thanks very much for watching. Have a great week if you can, and remember to just have a think. See you next week.